You're going to do more with computations than just adding positive and negative numbers, but the thing we're going to focus on for adding and then tomorrow subtracting, well tomorrow and Monday, is going to be modeling the adding and subtracting, both with number lines as well as with these. When I went to one of our math meetings, they said with black and red chips. Remember we talked a little bit about Black Friday? These are businesses in the black, mean it's earning money, versus in accounting books, red means they're owing money. So black and red chips are sometimes used, hi, I'm going to use your table here. But we're going to use something a little bit more visual. Instead of black and white chips, we're going to use black and red chips rather. We're going to use black and red parts of zero. Because if you have a positive, which is black, and you have a negative, which is red, and you put them together and they create a zero, right? So we're going to use a visual like this, as well as the number lines that we're going to put in our notes to make sure that you understand why when you add and subtract positive and negative numbers, you get certain results. Because yeah, it's all fine and good to know the algorithm, go, okay, I'm just going to do this computation and get this amount. But to understand sort of why it works, why you end up with a positive answer versus a negative answer, hopefully these models will help with the understanding of it. So I need to get a few more of these. So everybody should have a bag of positive and negative parts once this group gets theirs. You don't have to take out all the parts, but we are going to demonstrate some stuff with them in a moment. So adding positive and negative numbers, first in our notes we're going to do the number line model. And the number line model is a little bit not necessarily exactly how you would intuitively do it. I'm going to show you what I mean by that in a second. So you can show addition on a number line with these 3 easy steps. Set it and forget it. Here's the part that I don't necessarily intuitively do. For some reason, someone's decided that to model on a number line before starting any operation begin at 0. That's the part that I don't personally always think to do, because even when I'm doing bedtime math with my daughter, and she has a problem that's like, now if you had 6 pieces of Easter candy and your friend added 2 pieces of, whatever, I'm like, well, don't start at 0 and count up to 6, because, she does everything with her fingers, she's still 4. I said, you already know that you have 6. Don't even put up to 6 fingers. You can just say, oh, I've got 6, so now 7, 8. So I kind of tell her to start at the number and then go up or down from that number. But for this modeling of it, they want us to start at 0 and show going to that first number. And to show that movement, we're going to move on the number line to the first number. To show that movement, we've got a couple of options. We can sort of bounce over to it, but then you show an arrow saying I bounced in this direction to get there. Or you can make a straight line to it, so we're going to show both in our notes. But then again, you have to show the arrow, so you show the direction of that movement. And then the last step is to move to the right, or up the number line, when you're adding a positive number. You want to make sure you increase when you add a positive. So therefore, you're going to move to the left, the proper number of places, to add a negative number. And that's a little explanation of how we're going to show it. Now we're actually going to show it. So this first one, -6 plus 2. I'll show the bouncy way first. You start at 0. Oh, not quite lined up. Hopefully you're lined up better. And you go bounce, bounce, bounce to your -6. And then you draw an arrow to show that's the way that your movement went from 0 to 6. Or -6 rather. So 1, 2, 3, 4, 5, 6. Mine's not quite lining up perfectly. But then plus 2. Plus 2 is going to go up the number line just like it's always been when you needed to add 2. So bounce, bounce. And where do you end up when you have -6 plus 2? Yes, sir?
-4.
-4. So that's the number line model. Now, the parts of 0 model, or the black and red pieces model, remember, negative is red in an accounting book, so take out 6 of your red pieces. One, 5, 6. So take out 6 of your red pieces. Now add to it 2 of your black pieces.
6 red.
First take out 6 red, because we're starting with negative 6. And then add to it 2 of the black pieces. And then pair up as many as you can, so that that value would go away to 0. And what we have left should be 4 negatives. And this, the black-red chips kind of model, is more like what you might really try to think of in a real-life situation. Oh, it's like if I owed 6, and then I earned 2, so I was able to get rid of 2 of those 6 that I owed. So it kind of goes along with like your real-life scenario of owing and then adding in a positive amount to take away some of what you owe. For the next one, the number line model is going to start at 0 again. We're going to go to negative 6 again, but this time I'm going to show you the straight. You could do sound effects, you don't have to. But if you do, you do quietly to yourself. So from 0 to negative 6, 1, 2, 3, 4, 5, 6. My things aren't quite lining up, so that's negative 6. And then plus negative 2. So a lot of times I see that it goes up and then shows it going over 2 more. And my numbers are not matching up with my label, but hopefully yours are, right?
Yes, they are.
So where do you end up? If you go back from 0 to negative 6 and then you go down 2 more, where do you end up?
Negative 8.
Negative 8. And now, go ahead and do the same thing but with your red chips, or red parts of 0. First you start with 6 negatives, and then you add in 2 more negatives. And again, this whole red and black model, it is more like a real life type of making sense of it. If I owe someone 6 and I owe someone else 2, that means together I owe 8. So the number line is good to make sure you're like going the right direction and all, but then the black and red chips or parts of 0, they get either more of a real life situation, you owing things versus making money. Owing money, making money. A lot of times that's how they end up thinking about positive and negative. There was one that I saw somewhere was like owing library books, and then subtracting the negative is like bringing back the library books, taking away what you owe. So we'll play around with that a little bit more tomorrow too. All right, the last example I'm just going to show you on the number line with a combination, bounce and a straight arrow. So from 0 to 6, doing that with a straight arrow. Wild and crazy, except it doesn't really line up, but if it did.
Why are we using a straight arrow now?
I don't know, just for funsies. So 1, 2, 3, 4, 5, 6. And again, make sure you show the arrow says I went to this first location. And then plus negative 2. Notice this negative 2 is a raised negative symbol, as opposed to the previous example we put it in parentheses because it looks so much like a subtraction sign. So you're going to see a combination. Sometimes you'll see a raised negative symbol. Sometimes you'll see it put in parentheses. But now we have to go plus negative 2 means well, mowing. And where do we end up with that if we have 6 plus negative 2? Excuse me.
4.
We end up at 4, hopefully. And with your positive negative pieces, start with your 6 black pieces this time. 6 black pieces, and then add in 2 of your red pieces. So this would, in a real life situation, be like, I just made $6. Woohoo! Yeah! And someone goes, oh yeah, but it's only 2. Oh, yeah. And I still get to keep 4 for myself. So the whole logistical idea. So I'm going to pause the recording so you can then try the next 5 problems that are on your, okay, I'm going to attempt to pause the recording. Try the next 5 problems while I pause the recording and orient the board. All right, for the first one, negative 3 plus 4. What should we get when you do negative 3 plus 4? User. 1. We should get 1. And again, logistically trying to make sense of it. I owe 3 and then I earn 4. I get to keep 1 for myself. Or you could visually do it on the number line. I go down 3 and then when I go up 4, it takes me past the 0. What about if I have 7 plus -6? Ma'am,
1.
this is also 1, but this time I started with the 7 in my pocket. And I went to the thrift store and they said I owe 6. So I said, keep 1 for myself. But I got some good clothes. Okay, anyway. What about -3 plus -2? You turn it back.
-3 plus -2,
Uh-huh.
-5.
Should be -5. I owe 3 to this thrift store and I owe 2 to that thrift store, so I owe 5 altogether.
Stop being attention.
I have to turn that so fast when it comes on the radio. What about -3 plus 2? You, ma'am.
Wait, -1.
-1. So if I go down 3 and then I go back up 2, I'm still not quite to 0, I'm at -1. Or if I owe 3 but then I earn 2, I still owe another 1. And then the last of the examples before we go to the algorithm, if I have 3 plus -9,
-6.
I should end up with -6.
Yay.
So if I earn 3, but then someone comes around and says, yeah, but you owe me 9, I still get to, I'm only able to pay off 3, I still owe 6 more. So I'm going to go ahead and clear that ink so we can then just put in the algorithm. Because unless it specifically says that you need to model it, you can just use the algorithm. So when adding numbers of the same sign, you need to add their absolute values. And give the result the same sign. So if you have some positive and then you get some more positive, together you get a combined amount of positive. If you have the negative and then you get some more negative, you have a combination of a bunch of negative. So someone at one point came up with a mnemonic, same sign, sum. If you're adding up positive and negative numbers, same sign, sum. Sum up the parts that you got. To add numbers with different signs. You need to subtract their absolute values. You've got to find the difference of their absolute values. The order depends on which one has the bigger absolute value. And give the result the sign of the number with the greater absolute value. So it's because you went up past 0 and then you backtrack, and you didn't quite backtrack enough. Or you went down below 0 and then you backtracked up and you didn't go past. So it's that whole idea of what did you get more of? Did you get past 0 when you went back and backtracked? Or when you paired up things, what did you have more left over? So you're going to try some practice on the back side of your notes, please.